Take a look inside your phone, your laptop, even a satellite orbiting the planet right now. They're all hiding the same secret: a green surface, covered in patterns that look almost identical. But here's the question no one asks. Why is it always green? Because this was never required. Circuit boards can be red, blue, black, even transparent. Some companies actually make them. So why did the entire tech industry, across decades, across countries, across languages, all land on the same color? We customize everything: phones, cars, lights, cables. So why not this? And here's where it gets strange. Even today, when we have the technology to change it, we still don't. Why? The answer has nothing to do with technology. To understand it, we have to go back, way back, before smartphones, before laptops, back when electronics were a mess. I'd wires everywhere, fragile connections, constant failures. Every component had to be connected by hand, which meant more wires, more errors, and more places for things to break. Even a small vibration, or a loose connection, could shut everything down. Then came the printed circuit board, a flat surface that organized chaos into precision. Instead of wires running everywhere, thin copper pathways were etched directly onto a board. Clean, repeatable, reliable. For the first time, electronics could be mass-produced with consistency. But there was a problem. These early boards weren't green. They were brown, rough, inconsistent, made from materials that were difficult to refine and even harder to work with. And at the time, there were no automated inspection systems, no AI, no cameras, no scanners. Everything depended on human eyes. Engineers had to spot microscopic defects, by hand, under magnification, for hours at a time. Hairline cracks, barely visible breaks in the copper, microscopic failures no scanner would catch. And after hours of that, their eyes started to fail. Fatigue, blur, missed defects. A single missed defect could destroy an entire system, not just a computer, a communication system, a military device, critical infrastructure. So the industry faced a strange problem. Not performance, not cost. Human vision. Manufacturers began experimenting with coatings, different materials, different finishes, trying to find something that made boards easier to inspect. And that's when something unexpected happened. Green worked. Not just because of its color, but because of what it did to contrast. Against bright metallic copper lines and shiny solder points, green created a background that made even the smallest details visible. And there's a reason for that. The human eye is more sensitive to green than any other color. We can distinguish more shades of green, detect more variation within it, and sustain focus on it longer than almost anything else in the visible spectrum. Green also reduces eye strain. Unlike harsh, saturated colors, it doesn't overwhelm the eye over extended use. Engineers could work longer, see clearer, catch more. But green didn't just help human inspectors. The material used to create that green layer, the solder mask, turned out to be remarkably well suited to manufacturing. It protected copper from corrosion, stopped solder from spreading where it shouldn't. Durable, affordable, scalable. A green wasn't just easier to see, it was easier to build. So what started as a human solution to a human problem quietly became the industry default. Factories were built around it. Processes were optimized for it. Global standards were written for it. And here's where the story gets interesting. Because today, machines can inspect circuit boards better than we ever could. More accurately, more consistently, with cameras that detect flaws no human eye could see. The original reason for green is essentially gone. And yet, we're still using it. Not because it's the best option, because everything is already built around it. Changing the color means reconfiguring machines, retraining workers, rewriting specs, and risking new defects in the process. Entire factories, global supply chains, quality control systems, all designed for one color. And when something is this embedded, industries don't experiment. They protect what works. So the color that defines modern electronics wasn't chosen by engineers optimizing for performance. It was chosen because human eyes got tired. A biological limitation quietly shaped the hardware of the entire modern world, and it became so normal, so expected, that no one questions it anymore. The next time you crack open a laptop or glance at a circuit board, you'll see it differently. Not a technical choice, a human one. This is hidden in plain sight. Subscribe. Because that green board sitting inside your phone right now was never about the machine. It was always about you.